All right, so now what we're going to do is take a look at the situation where we have a two-dimensional force situation where we have, different charges and we want to find the superposition. Now on this one, they're not all on the same axis, right? And so we're going to have to consider that as we figure out the superposition here. We want to find out what is the force on the 4 microcoulomb charge. So again, what we do with this is we do what we did kind of before, where we ignore one, and figure out, what happens with the others. And so, if we want to call, let's go ahead and call the bottom left Q1, the top Q3, and the one on the right Q2. Okay, so, let's say we just wanted to concentrate on these two down here. What we would do is we ignore the top one, and we say, okay, I've got this charge and I've got this charge. Both are positively charged. So the force on Q2 due to Q1 is equal to K Q1 Q2 over R squared, right? How is this charge going to be affected by Q1? Well, it's going to be pushed to the right, right? And all we care about is what happens to this. Q1 is going to be pushed to the left, sure, but we don't care about that. All we care about is the force on the 4 microcoulomb charge, which is this one, right? So that's going to be blank newtons to the right. So let's go ahead and do that first. Go ahead and calculate that, and then we'll take the next step after that. So go ahead and do that, and then you can start the clip again. All right, so we should get 0.072 newtons to the right would be the force on charge 2 due to charge 1. Now what we're going to do is we're going to say, okay, this one doesn't exist. All we care about is these two charges. This one's negative, this one's positive, right? So how is Q2 going to be affected by Q3 here? Well, there's going to be an attractive force like this, right? And it's up at an angle. So this is the first time where we're dealing with something that's not on the same axis, right? So what we do is we're going to calculate that force, that raw force. We have a certain radius that we're going to have to find out. You can use this graph to do that. You have the certain radius here. We have the two charges. So go ahead and calculate that raw force. You can pause the clip here. Go ahead and do that, and then when you've done that, you can hit play to continue, and we'll look at it. All right. So it's a 45-degree triangle, and each length is 1 meter. We have our reference here, so 1 meter by 1 meter. So 1 squared plus 1 squared equals c squared, which would be what, 2 equals c squared. So square root of 2, about 1.4 meters. Okay, so that's going to come in there. And which way is the force going to be? Well, we've got 0.05 newtons, 45 degrees above the x-axis. This is a problem though, right? Because before it was all on one axis, but this one is on just the x-axis. This is on the x and y. So if you remember back with displacement in your junior year, right, where we took the vectors, we broke them into the x and y components, we're going to do the same thing here. We're going to take this force and get the x component and the y component of it. We're going to break this down into what is the x force, what is the y force, and then use those two forces for our total x and total y. So when we use the sign, this is the opposite side, we get this, and then for the adjacent side, cosine, we get this. We can get our total x and our total y. There's only one y force, which we found, just breaking up this triangle here, breaking up this force. But now we have two x forces, right? We had one that was to the right, and then one that was to the left, and the one that was to the left is this one right here, which is that portion of it. So that's a negative here. So we get our total x, total y, and then we can use Pythagorean theorem for those two forces, total x, total y, and we'll get 0.051 newtons, 48.5 degrees above the x-axis. So, we go over here, positive 0.033 and positive 0.03818. And then you can get the resultant, which is 0.051 newtons, 48.5 degrees above the x-axis. All right, so now on this one, we want to find out the force on the -3 microcoulomb charge. We'll call the top left Q3 again, and then the bottom left Q1, and then the bottom right Q2. So what I want you to do on this one is try this one on your own. The easiest one to do is probably ignore this first and then get the force between Q3 and Q1 first. So force on Q3 due to Q1, Q3, Q1 over R squared. Do that one first, and then yeah, see if you can work through the other one, and then and I'll go ahead and erase that so you can at least see it now. You can work through this one, and then get the superposition. So go ahead and pause the clip and give this a try. And when you're ready to check, you can hit play to continue. All right, so the force on Q3 due to Q1, well, this is negatively charged. This is positively charged. Q3 is going to be attracted, so it's going to be a downward force, blank newtons down. And so we end up getting 0.054 newtons downward. And then if we ignore this one, right, Q3 is going to be attracted to Q2, so it's going to be a downward and over to the right force. And we can use the triangle to figure out the radius there, which again, Pythagorean theorem, we can get that. And so this is going to be 0.054 newtons, 45 degrees below the x-axis. And so we have our two forces, and again, this one is not lined up with, you know, either the x or y. We're going to have to break it up into its components. And when we do that, we can use the cosine to get the value there and the sine to get that value there. And then I actually just see an error here. You know, if I look at, and it's at a 45-degree angle, which is going to work out. But if you notice here, like for x, right, if I break this force up into this and this, it's actually cosine will give me what's going on in the y, and then the sine is going to give me what's in the x. But these values should be 0.03818 for each of those. And then so down and then to the right. And so those are the two forces. We have our total x, total y. In the x, there's only one force, and that's to the right. In the y, they're both downward, right? So they're going to add up downward for a total amount. And when we do our vector addition, we should get 0.0998 newtons, 67.5 degrees below the x-axis as the resultant.